Okay, so these are notes on function notation and evaluating functions. So first we're going to start with something that you already know. Y equals 2x plus 4. If I had x equals 3, what we would do is we would plug that 3 in to the x. So we would do 2 times 3 plus 4, 6 plus 4, 10. So we would get this x and this y. Okay, what if we did it for negative 2? X equals negative 2, we plug it the same way. And we do the math. And we get 0. So here's our x, here's our y. We can do it again for x equals 0. So 2 times 0 plus 4, y is 0 plus 4, y equals 4. This is our x, this is our y. You've done this before, this substituting in a variable, a number for the variable, and solving. So I could make these ordered pairs, 3, 10, negative 2, 0, 0, 4. Or I could make them in a table, right? I could do x, y, and I could make 3, 10, negative 2, 0, 0, 4. Okay, we know how to do all of this already, I think. Now what we're going to do is we're going to introduce something else. We are going to introduce that instead of y equals 2x plus 4, we have something called f of x. So we are now, instead of writing it as y equals, we're going to write it as f of x equals 2x plus 4. This is called function notation. Okay, it is another way to say y in a very simple term. It's not the best definition, but for right now, we're going to say that f of x is another name for y. And we're also going to talk about how we say that. So we're going to say f of x is another name for y. It's basically another name for the output, right? Because down here, we had inputs of 3, negative 2, and 0, and we had outputs of 10, 0, and 4. So we always know that x equals is our input and y that we get when we plug it in is our output. So we say f of x as f of x, okay? Now, when we evaluate the function, if we have f of x equals negative 4x plus 7 when x equals 2 and x equals negative 2, we're going to do the exact same thing that we did down here when we started out. We are going to put our input in and we're going to get our output out. How we would write this is f of 2 equals negative 4x plus 7. This is like shorthand, right? You don't say be right back anymore, you put BRB in the text. You don't say, oh my gosh, you're an idiot, you just put SMH because that's all you can do. So this is basically shorthand. This is telling you that you want to find y when x equals 2. So we're just going to plug that in. Negative 4 times 2 plus 7. Here's the 2, goes in where the x is, and we're going to solve. Negative 8 plus 7. So f of 2 equals negative 1. Okay, we're going to do the same thing for negative 2. So we have f of negative 2 equals negative 4x plus 7. This is still x. We're still going to plug it in here. Remember, this is like shorthand text language. So we're going to plug in the negative 2 or substitute in the negative 2. We're going to get f of negative 2 equals 8 plus 7. F of negative 2 equals 15. Can I still write it as an ordered pair? Sure. My x is 2. My y, or my output, is negative 1. My input is negative 2. My output is 15. Goes in a table, goes in an ordered pair. Okay, we're going to do just a few more examples so you get the hang of it. We're going to do B right here. it doesn't matter if it says f of x or g of x or h of x. Okay, the only letter we don't really use is s. So we're going to do -4 and 3. So we have g of -4 equals -x minus 1. And we have g of 3 equals -x minus 1. Now, what happens here is that we're going to plug this in. We have a -4 and we have a negative. So we need to make sure that we don't just gloss over that. We need the negative to come down from the original problem, and we need the -4 to go in. So g of -4 equals 4 minus 1. So g of -4 equals 3. Okay, then we're going to do 3. So we're going to plug the 3 in. -3 minus 1. When it's positive, it's okay because the negative and the positive make a negative anyway. So g of 3 equals -4. Input, output. Now you can understand a little bit of why it's a lot like y, because x over here is input, y over here is output. We are just giving it another name and we're writing it in a different way. Okay, I want to do C with you because it is squared and it's important that we do PEMDAS in a way that makes sense. So we have h of x equals 3, not h of x, h of -4, sorry, 3x plus 2 squared. And over here we have h of 3 equals 3x plus 2 squared. All right, so this is 4. So we're going to plug in a -4 here. So all I did was plug it in. I just replaced the x with the number -4. Now we're going to do parentheses first. -4 plus 2 is -2 squared. Now we're going to do exponents because that's how PEMDAS tells us to do it. Now, -2 times -2 is 4. So h of -4 is 12. Input, output, input, output, x, y, x, f of x. All right. You'll notice in your calculator, if you put this in the calculator as -2 squared without the parentheses, it won't work. You have to use the parentheses. Your calculator only goes off of PEMDAS, so if you don't put the parentheses on it, it doesn't know to square the whole thing. Okay, here we're going to do h of 3 equals 3. 3 plus 2 squared. We're going to add them together first. Then we're going to square 5 squared is 25. And then we have h of 3 equals 75. Input, output. X, y, x, f of x, input, output, input, output, input, output. Okay, it's things that you've already done before. It works the same, even if it has something scary like this. That's a fraction. So if I did f of 3 equals x over 3 plus 4, I'm still going to take this 3 and plug it in for the x. 3 divided by 3 is 1. And 1 plus 4 is 5. Again, I could write this as x, this is f of x, or what we would call y. Still, here's how it looks as an ordered pair. Okay. I think that's all we're going to do for right now. We will do the second part as we get to it. Please watch this video over and over again because it will help you. And if you have any questions, you need to text me over Remind or email me.